Now let's talk about AWS Managed Policies. As I have rightly quoted AWS here, an AWS Managed Policy is a standalone policy that is created and administered by AWS. Remember this line very carefully. These managed policies that we see here are created and administered by AWS itself. And as I told you that AWS Managed Policy is a standalone policy. Standalone policy means that the policy has its own Amazon resource name that includes the policy name itself. Like we have ARN for IAM read-only access, and this is also an AWS Managed Policy. And one thing that you need to remember here is that you don't need to create this policy on your own. It is already created by AWS for you. And you might ask, why is AWS doing this? What is the use? And the biggest advantage of these policies is that they are maintained and updated by AWS themselves. In case a new service or API operation is introduced, then the policy for that are being created and managed by AWS themselves. For example, in IAM, we have a policy called Administrator Access, which provides full access and permissions, delegation to every service and resource in AWS. And that is not created by you or me. It was already created by AWS. So remember that. And here, you cannot change the permission defined in AWS Managed Policies. That's a good thing actually. You don't need to mess up everything that is already there in AWS. And the biggest advantage of using Managed Policy is its inclusiveness. This is account 1 and it has users, user groups and roles. Like we can see here, we have group admin user Dave, John, we have user Jenny, we have role EC2-app and role third-party access. And these managed policies like administrator access, power user access can be attached to them. But not just that. The same policies can also be used by users across accounts. And that is what makes it special. So these policies are already defined by AWS and can be used across accounts by anyone who wants to use it. Along with managed policies, we also have customer managed policies. Unlike AWS managed policies, with customer managed policies, we can create standalone policies that we administer in our own account. And these policies are referred to as customer managed policies. Here we create the policies for our own AWS account. So you understand the difference? AWS managed policies are being created and managed and administered by AWS, whereas customer managed policies are being created by us and administered by us for our own AWS account. We create the policies for our AWS account. And if you can see here, we have 3 customer managed policies: account admin MFA, limited admins MFA, and EC2 access. These policies are created by us for our own account and thus can be attached to users, groups, and roles in the account, similar to what we have for the AWS managed policies. And a very good point mentioned in AWS document is that a great way to create a customer managed policy is to start by copying an existing AWS managed policy. So we have a lot of AWS managed policies, and if you want to create a custom policy from that, you can actually copy that AWS managed policy and then you can actually customize it for your requirement. And that way you know that the policy is correct at the beginning, and all you need to do is customize it for your requirement or environment. Hence, if you would like to create a customer managed policy, go ahead and copy an existing managed policy and modify that for your requirement. So it's a very good thing that we already have the policies, and if you want to make use of them and we want to customize them, we can do that by starting off by copying them, and we can modify them as per our requirements. So just like I told you, there are 2 types of policies. There are managed policies and inline policies. So next is inline policies. These also serve a particular use case. Let's read this. An inline policy is a policy that's embedded in an IAM identity. So what is the identity? It could be a user, group, or role. And the policy that we have here, the inline policies, are an inherent part of the identity. And you can create a policy and embed it in an identity either when you create the identity or even later. I know it's hard to understand, but let me explain this. An inline policy is created and managed by you. I hope you got that. It is created and managed by you, and it is embedded directly into a single user or a group or a role. And when you delete the user or the user group or the role, the inline policy is also deleted. And that's what it means when we tell it is an inline policy, because it has a one-to-one relationship with its entity. If you see the image here, we have the policy account admin MFA. It is attached to a single group called group admins, where we have two users, user Dave and user John. And the next one that we have here is role EC2 app, has an inline policy called policy EC2 access. And the other one that we have is role app account, which also has the same policy EC2-access. And here you might have a doubt if these two are the same policies. So let's check the first point on the right hand side. Two roles include the same policy, the EC2 access policy, but they are not sharing a single policy. Each role has its own copy of the policy. Be clear in your mind that these are its own copies of the policy being attached to an individual role. Even though the names are same, the content might be same, but they are the own copy of the policy. The third point that we have here, you can see there is a strict one-to-one relationship between the entity and the policy. I have already explained this. The last point is also very important about inline policy. When you delete the user, group or role in which the inline policy is embedded, the policy will also be deleted. And that's because they are the part of the principal entity itself. When you delete the user, group or role, the inline policy is also deleted because it has a one-to-one relationship with its entity. But there is a question that arises here as well. When should we use managed policies and when should we use inline policies? That's a very good question. Let's see that. And now let's talk about choosing between managed policies and inline policies. And when I talk about managed policies, it covers both AWS managed and customer managed. Remember that. I'm talking about both of them. So managed policies provide the following feature. First is reusability. It's a very important feature. We already know that a single managed policy can be attached to multiple principal entities. Yes, we can. And we can either use the already existing AWS managed policies or even create a pool of policies that can be attached to the principals. The next one is central change management. Here, when you change a managed policy, the change is applied to all principal entities that the policy is attached to. Let's suppose there are 100 users and one policy is attached to them. When you change the managed policy, it reflects across all the principal entities. Hence, when we want to refactor a policy and make the intended change, it actually gets applied to all the principals that the policy is attached to. And this is a very good advantage over inline policy. For example, if a group and a role both contain the same inline policy, you must individually edit both principal entities in order for the change to take place. That's not required with the managed policies. Next one is versioning and rollback. This is also a very good feature because when you change a customer managed policy, the changed policy does not override the existing policy. Yes, it does not. Instead, what IAM does is that it creates a new version of the managed policy. And IAM actually stores up to 5 versions of the customer managed policies. That's a very good thing. And with that, you can use policy versions to revert to a policy to an earlier version if you need to and if you don't want to. And that's how you can do that versioning and the rollback. And the next one is delegating permissions management. And let's suppose you are an admin, hence you would have permissions to create and delete and manage the policy. Right. And you can control how your users can apply the managed policies. But having said that, we can also create admins with limited access. And what is the use of that? These limited access admins can also help us delegate policies which are allowed for them to attach to other principals. For example, by using policies like delete policy version, set default policy version, IAM attach group policy, IAM attach role policy. And by this, we can actually delegate policies. The last one that we have here is automatic updates for AWS managed policies. As I already told you, AWS manages or maintains AWS managed policies and updates them. And that is not your headache. So it's a good thing. For example, if a new service or API is introduced, AWS itself will maintain the policy for that resource. So that's not your headache. That's a good thing. Next is inline policies. Let's see what we can do by using inline policies. Inline policies are useful if you want to maintain a strict one-to-one relationship between a policy and the identity to which it is applied. Sometimes what happens is you want a user to have a single access or one-time access, then you can just define a permission for that. And once the user has performed the operation, then you can just delete the user or the policy along with that. And that way you can actually use inline policies for that particular time. And the next feature that we have here is when you use the AWS Management Console to delete that identity, the policies embedded in the identity are deleted as well. So that's a very good benefit. And these are the benefits of using inline. And it's not that managed policies are superior in every way possible. Rather, it depends on the use case. So it will be dependent on the use case on whether you would want to go with AWS Managed Policies or Managed Policies in general, or you would want to go for the inline policies. Now let's understand permission boundaries in a way that you can relate with. By now, we already know that a permission boundary is a feature of AWS for using a managed policy. Remember that it's a managed policy to set the maximum permission that an identity-based policy can grant to an IAM identity. It's a bit confusing, but keep this point in mind. It is going to set a maximum permission, but it does not on its own grant permissions. Okay, it is going to set the permissions, but on its own, it is not going to grant permissions. Suppose I tell you, you are only allowed to play in a play area. Let's suppose this is the room, and I tell you that you are supposed to play in this area itself. And I tell you just that and nothing else. And you would think that it generally does not tell you what toys you can play with. Similarly, the permission boundary can set the maximum permissions but does not specify granting them. Thus, if your identity-based policy allows you to work with EC2 and Lambda, and if your permission boundary restricts permission to only till EC2, then even though you have permissions to use Lambda, your boundary will not allow that, and you will not be able to use Lambda. Still confused? Let's check this example. When you create an IAM user, you can attach policies and as well define its permission boundary. Remember this. And you can use AWS Managed Policies or customer managed policies that you already created to set the permission boundary as well. Yes, when you create the user, you can always attach policies and as well you can set the permission boundaries. Generally, we don't do that, but you can do that as well. For example, this is user A's permission boundary. And why is it called a permission boundary? Let's see this. So what does it say here? So if you read the policy here, the effect is allow and the resource is star, which means it has allow permission for all resources. If you see these two statements, allow and resource star. The action that you see here tells us that it has only access to perform actions on these operations. That is S3 star, CloudWatch star and EC2 star. So the user who has this permission boundary can only work within these three services, S3, CloudWatch and EC2. And therefore, the permission boundary will not allow any other service operation to be performed by user A. Yes, that's true. If this policy is attached, if this policy is also attached to user A, which allows IAM create user functionality, this operation will not be applicable because of its permission boundary. And that's where you need to understand a concept called effective permissions. The block that you see here is the permission boundary for user A. And we have the identity-based policy attached to user A. And if a policy residing between them doesn't restrict itself under the permission boundary, and it still exists on the identity-based policy in the Venn diagram, then these policies are called effective permissions. And effective policies are the intersection of both types of policies, like this one and the permission boundary. And yes, an explicit deny in any of these policy overrides the allow. So I hope you got the point. So this is the permission boundary, and within which we have two policies, and this also is within the identity-based policy. So I hope you got the point. Let's move on. Now let's talk about the session policies. It's also a very important concept. And as we already have discussed before, when you think of session, you imagine a scenario where you want to provide a mechanism where each request can be validated that it's being sent by the same user. Session policies are similar to that. Hence, session policies are advanced policies that you pass as a parameter when you programmatically create a temporary session for a role or even for a federated user. But now you will ask me, how will it get permission then? The permission for the session comes from the IAM entity, which is a user or role, which is used to create the session and form the session policy. Thus, if there is a session, there will be a session policy, and we need to pass the session policies so that the principal can perform the operation. And we can create role sessions and pass session policies programmatically using the assume role with SAML, or assume role with web identity API operations. And we can use policy ARNs to specify up to 10 managed session policies. And here also we have a concept of the effective policy or the effective permissions for this set of policy types. And these are the intersection of these three policy types, which is session policy, the permission boundary itself, and the identity based policy. And the intersection defines the effective permission for the session policy. And an explicit deny in any of these policy overrides the allow. So look at the flow diagram here. This is a very good way to understand the flow. And before moving forward, just keep in mind a session principal, or the one who is sending the request, is going to be either a role session or an IAM federated user session. Let's check this diagram. In IAM, when you start with a request, the decision making starts with a deny. Now we evaluate all the applicable policies that the request has. If there is an explicit deny in the policy, or any one of the policy or any one of the statement, then the final decision is deny because it has an explicit deny. So this is called the deny evaluation. If there is no explicit deny, it goes to the second condition and checks is the principal's account a member of an organization with an applicable SCP. So if there is a SCP being applied to this, if it is yes, and it checks again, is there an allow there? If no allow is there, then the final decision will be implicitly denied because there is no SCP applied to this. So this is called the organizational SCP. So if there is an applicable SCP but there is no allow, then the organizational SCP will have an implicit deny and the final decision will be denied. Else, if there is a allow, then it will check, or if this condition also fails, then it comes to this condition where it checks, does the request resource have a resource based policy? So it will check whether the request has a resource based policy there. Now what happens if there is a resource based policy? Then it will check whether there is an allow, and if there is an allow, the resource based policy will determine what has to be done and how it has to be allowed access for. And if there is no allow and there is no resource based policy, then it will check, does the principal have an identity based policy? So if there is a policy attached to the user, group, or the role. If not, then the implicit deny will apply because that's the identity based policy and the user doesn't have any permissions or policies attached to them. So that will be an implicit deny. And if yes, it does have identity based policy, and we'll check whether there is an allow or not. So if there is no allow, then it also has implicit deny. And if it is yes, if there is an allow, then it goes and checks whether there is the permission boundary attached to it. Does the principal have a permission boundary? And if there is a permission boundary attached to it, and it will check whether that condition within the permission boundary has an allow there. So if there is no allow, then it obviously will be an implicit deny because there is no explicit allow there. So now if there is an allow, it will go there and it will check if the principal is a session principal. So if it has been asked from the session principal itself. So if this is the session principal, then it will check, is there a session policy attached to it? So we have to pass it programmatically, as I told you, the session policy. And in that, if suppose there is an allow, then the final decision will be allowed. If there is no allow, then the implicit deny will be the action that is going to take place. And if there is no session policy also, it will check whether there is a role session or not. If there is no role session, it will be implicitly denied. If there is a role session, the final decision will be allowed. And the same goes if it is not a session policy, because it does not have a permission boundary and it has a allow in the principal as a identity based policy. If these conditions are satisfied, then it will automatically be allowed. Okay, for the session principal, it will check if there is a session policy. If there is an allow in that, if yes, then it allows the final decision and the final decision is allow. And if not, then it goes with the implicit deny. And if there is no session policy, then it will check for the role session. And if there is a role session, then it will have the request to be allowed and that will be its final decision. So I hope you understood the point. This is a very good example of understanding how the flow actually works when a request comes. So please make sure that you go through this once again, read more documents about it and see the flow diagram and try to understand. And if you want to understand it again, and if you skipped any of the portions, then please don't do that. So I hope you got the point here. And if you want, you can just reiterate this portion once again and watch this again so that you get an idea about it. And if you have any doubts, then please post them in the comment section below. Now let's understand the difference between identity and resource-based policy. I know you have been waiting for this. So the subjective definition tells us that identity-based policies are attached to an IAM user, group, or role, which are indirectly, we also call them as identities, isn't it? And these policies let you specify what the identity can do. That is, its permission. And on the other hand, the resource-based policies are attached to the resource. So identity-based policies are attached to identity, resource-based policies attached to resource. Simple. For example, you can attach resource-based policies to Amazon S3 buckets, Amazon SQS queues, VPC endpoints, and AWS Key Management Service encryption keys. The most important thing you need to understand here is that even though the user doesn't have an identity-based policy to perform operation on a S3 bucket, if there is a resource-based policy that allows full access to the principal, then that user, the user group, will be able to operate on that bucket. I hope you got the point here. Even though the user doesn't have an identity-based policy to perform operations on a S3 bucket, if there is a resource-based policy that allows full access to that principal, that user or that user group will still be able to operate on that bucket. Now let's see this example here. First, we have the identity-based policy. So here we have user A who can perform list read operations on resource A. We have user B which can perform list operation, read operation on resource B and C. User C which can actually list, read, write on resource A, B and C. All three of them, all three A, B and C. User D has no policy attached, so it does not have a identity-based policy attached to it. Next, we have resource-based policies, and the first resource-based policy is for resource A, in which we are allowing user A to perform list and read operations, and we are also allowing user C to perform list and read operation. Now we have resource B, resource-based policy for resource B, where we have user B, and for user B, we are allowing it to perform list operation and write operation. Similarly, we have a user D, which can actually perform list operation and read operation. The last one that we have is for the resource C, where user B is denied access to resource C. So there is a deny access in the resource-based policy for the resource C. And user D has allowed full access. So user D has full access to resource C. And this is a total policy implementation of the AWS account. Now let's see how it actually affects. So if we see this chart here, we have 4 users, A, B, and C, and D, and these are list of operations: list, read, write, denied access, and full access. And if we take into consideration the identity-based policies and the resource-based policy, for user A, it can actually list on resource A. If you see, we have a resource A, user A can list and read. Here also, user A can list and read. So list and read operations are allowed for on resource A. And write operation, we don't see any write operation on any of other resources. So write, denied full access or full access is not applicable here, because we are not denying full access for anything. Now let's come back to user B. It can list and read on resource B and C. But when we go to resource C, it has denied access. So now user B can perform list and read on B, as the resource B policy also said that it can list and write on resource B. So now it has 3 operations: list, read, and write. But on resource C, B does not have any access. So now it can perform list operation on resource B, it can perform read operation on resource B, and write operation on resource B. But it has denied full access on resource C. So user B cannot perform any operations on resource C and resource A as well, because it has no access. So it is an implicit deny. Now let's see for the user C. It can perform list, read, write on resource A, B, and C. So resource A, B, and C, it can list, read, write. And here, if you see, we have a mapping argument on the resource A, where resource C can list and read. And there is no other policy for user C here in resource B and resource C. So all that matters for now is the identity-based policy, as this is allowing user C to perform operations on resource A, B, and C. Those operations are list, read, and write. So it has access for list, read, write on all the resources that we have A, B, and C. Now let's come back to user D. If we see user D, let's see what Yeah, so here we have resource B, it can list and read. So now we have written list and read for resource B. And now on resource C, it has full access. So full access is given to resource C. And other than that, as it doesn't have any identity based policy and we don't have user D on the resource A part, so whatever applies will be applied on resource B and resource C. And that is why user D is able to perform operations on resource B that are list and read. And thus it does not have any write permissions, or it does not have a permission that actually tells it is totally denied access, but it still can perform operations on resource C because it has allowed full access. So now that you have to understand is, even though the user doesn't have a identity based policy attached to it, if there is a resource based policy that allows full access, then that user will be able to perform the operation on that particular resource. Now let's see this once again. For identity based policies with boundaries, the effective permission is the intersection of permission boundary and identity based policy. So this is its effective permission. And this is identity based policies with boundaries. Next one is the effective permission of resource based policies that lies between the union of identity based policy and resource based policy and the permission boundary. But there is one difference here. And the difference is that the resource based policy is not dependent on the implicit deny. As I already told you, it is not dependent on the implicit deny. Implicit deny is like you haven't written anywhere in any policy that the effect is deny. And also if there is no policy there, then it means implicit deny. That is why if you see, even though a policy doesn't exist in the identity, this policy does not exist in the identity, but still if it is present in the resource based policy and the effect is allow, the permission will be granted, because this is a resource based policy and it does not depend on the implicit deny. That is why this is its effective permission. The last one is session based policy, and the effective permission for this set of policy types are the intersection between three policies. The three policies are session policy, permission boundary, and identity based policy. And the intersection defines the effective permission for the session policy, and an explicit deny, I am telling you this once again, and an explicit deny in any of these policies overrides the allow. So I hope you got the point between the differences between the effective permissions of all three use cases. So let's move on. And thanks everyone for joining in for today's session of AWS. I hope you got some of the information that you wanted. And if you haven't subscribed already, then please do so. Please comment and like the video. And that really helps me a lot and helps the channel grow and is a really motivating factor for me. So please make sure that you subscribe. It really takes a lot of work and a lot of hard work to actually bring in these videos. So please make sure that you support the channel by subscribing and liking the video. So I'll meet you in the next session of AWS. Stay safe, stay healthy. It's Pythoholic signing off.